So let's look at this simple Venn diagram where we have a universal set U and some set A inside. Now, if you were to talk about the set of elements that are not in A, set of elements that are not in A, that set would be given by this difference U minus A. So this would be the set of elements outside of the circle corresponding to A, but within the rectangle corresponding to U. So another way to write this would be U minus A would be the set of elements X such that X does not belong to A. Of course, we could also add that X belongs to U, but that is implicit. So when we say we're talking about elements outside of a given set, it's understood from the context that we are talking about we have some universal set U in mind with respect to which these elements are outside of A, but which are still within the universal set U. Now this set is given a special name. It's called A complement. Sometimes it's denoted as A with a bar on the top. So this is the complement of A. So the complement of A is the set of all elements which are not in A. For example, if U is defined to be the set of natural numbers from 1 to 10 and A is defined to be the even numbers 2, 4, 6, 8 and 10, then the complement of A would be the set of odd numbers 1, 3, 5, 7 and 9. So these are all the numbers which are not in A. And obviously you can see that A intersected with its complement will be the empty set, because the complement of A are all the elements which are not in A. So A and A complement don't share any elements in common, so their intersection is the empty set. But if you take their union, if you take A union A complement, that would be the universal set. What if we take the complement of the complement? So A complement is the set of elements which are not in A. If we take a double complement, if we take the complement of the complement, we get back the set A. So A complement would be the set A. Let's take a couple of more examples. Suppose U is the set of students in your class, and suppose A is the set of all students X such that X is a boy and X is a student in your class. Should probably remove these curly brackets here. U is the set of students in your class. A is the set of all X such that X is a student in your class and X is a boy. So A complement would be the set of girls in your class. So A complement would be the set of all X such that X is a student in your class and X is a girl. In other words, you can divide up the universal set U into two parts, the set of boys and the set of girls. Let's take another example. Suppose U is the set of all prime numbers and A is the set of all numbers X such that X is prime and X does not divide the number 42. So note that A is assumed to be a subset of U because we have defined a universal set here. So we don't have to specify that these numbers X will be positive, because it's understood from the definition of the universal set that we're only talking about prime numbers here. And we're talking about a particular subset of the universal set A, which consists of prime numbers that do not divide 42. So in fact we could have even omitted this because it's understood that we're only talking about prime numbers. So if A is the set of all prime numbers which does not divide 42, A complement would be the set of all prime numbers and which do divide 42. So what are the prime factors of 42? 42 can be written as 2 times 3 times 7. So these three are the prime factors. So A would be an infinite set. So the set U is an infinite set because there is an infinite number of prime numbers. A consists of all the prime numbers apart from 2, 3 and 7, because 2, 3 and 7 are the prime numbers which divide 42. So A complement would be the set 2, 3, 7 and A would be the set 5, 11, 13 and so on.